Assalamu alaikum. Today we are breaking down the magic of electrochemistry and I am going to make this complex topic crystal clear for you. So let's get a start without any further delay. First of all, electrochemistry is the interrelationship between chemical energy and electrical energy. So we can say that it is a combination of two energies. It is a branch of chemistry in which we will deal with about two concepts. One of them is that how we can generate electricity by proceeding a certain electrochemical reactions, and the second one is that how electricity can proceed certain electrochemical reactions that are unable to happen in its own. Now these electrochemical reactions are called redox reaction. Redox reaction are those certain type of electrochemical reactions in which reduction and oxidation take place at a time. Now let's discuss oxidation and reduction reaction briefly. First of all, oxidation is the loss of electron and reduction is a gain of an electron. Consider we have an equation where the zinc react with copper sulfate and convert into zinc sulfate and copper. Now you can see that here the zinc metal atom lost two electrons and becomes zinc metal ion. So we can say that here the oxidation of zinc take place. Similarly, these two electrons are gained by copper and the reduction of copper take place. And copper ion by gaining these two electrons becomes solid copper metal. So we can say that here reduction and oxidation take place at a time. So this is a redox reaction. Further, in this reaction, copper sulfate will be break down and sulfate ion will react with zinc ion and become zinc sulfate, and copper ion will reduce to become solid copper metal. Further, we can also say that oxidation is increase in oxidation state, gain of an oxygen atom and loss of hydrogen atom. And reduction is a decrease in oxidation state, loss of oxygen atom and gain of H positive ion. Let's jump into the next topic, oxidation state, also known as oxidation number. Basically, it is a real or virtual charge on any species that could be atom, molecule or compound. Charge on any ionic or covalent compound like zinc have +2, and here the +2 is an oxidation number. Now question arises that how we can find oxidation state in an non-ionic compound, means covalent compound. So here is some rules by which we can easily find out oxidation number on any compound, molecule or atom. First of all, any species in elemental, free, purest state always have an oxidation number of 0. Like hydrogen, sodium, sulfur all have oxidation number of 0. Monatomic or diatomic, both molecule, if it is present in their pure state, then the oxidation number will be always 0. The second thing is that element of first A like lithium, sodium, potassium, and second A like beryllium, magnesium, calcium always have an oxidation number of +1 and +2 respectively. Now as you can see in the first example of calcium oxide, where the calcium is belong to the second A, so we will write the oxidation number of calcium +2, and to balance +2 the oxidation number of oxygen will be -2. And you can look at the rest of example by yourself. Now the third one is that hydrogen typically exhibit an oxidation state of +1 when bonded to a non-metal. For example, in ammonia NH3, hydrogen is bonded with nitrogen, which is a typical non-metal. So here the hydrogen have +1 oxidation number. Similarly, hydrogen have -1 oxidation number with metals. Like in sodium hydride, hydrogen have -1 because it is bonded with sodium, that is a metal, and sodium have +1 oxidation number here. Oxygen generally have an oxidation number of -2. Exception for an oxidation number in peroxide will be -1. In superoxide, the oxidation number of oxygen is -1/2. And the oxygen usually have a positive oxidation number with fluorine. And the last thing, halogens generally have an oxidation number of -1. Thank you. Please don't forget to subscribe my channel.